This is Secondary 2 Honors Module for Module number 7, Video number 5. This is going to be about solving rational equations. So just to introduce the idea, you've solved equations similar to this before. I'm going to show you a couple ways to do it. The first way that you might think of doing it is to subtract 3, so you'd have 2 over x is equal to 5. You could then treat this like a proportion to your cross product, so 2 is equal to 5 times x, and x is equal to 2/5. And that's a great way to solve that particular one. I'm going to show you another way to do it because they don't all work like that, just because they can be a little bit more complicated. So another thing you can do is use the idea of common denominators, and you can say, well, if I had a common denominator here, actually I'm just going to take a side trip here. If I had 1/3 plus 1/6 is equal to x, one way you could do this is you could say if I have a common denominator of 6, that would give me 2 plus 1 is equal to 6, because if I multiply everything by the common denominator, that's what I would have. And then I could solve that. Another way I could solve the exact same question, or same problem, would be to say, if I wanted to make a common denominator of 6, this needs to be multiplied by 2 over 2. This doesn't need to be multiplied by anything. And this would need to be multiplied by 6 over 6. So I'd have 2 over 6 plus 1 over 6 equals 6x over 6. And since all the denominators are the same, I can just focus on the numerators and have 2 plus 1 equals 6x. So that's just one way that you can think about it. I like that way because for a lot of these problems that are like this one, that's actually one of the best ways to do this. So if I look at my denominators here, my common denominator would be x. So if I multiply this one by x and this by x and this by x, on this first one it cancels out. And this one I'm going to have 3 times x over 1, and this one I'll have 8 times x over 1. So then I'm going to have 2 is equal to 5x, and x is equal to 2/5. Alright, now one thing with rational equations, we have to worry about something called extraneous solutions. An extraneous solution is a solution that will result in an undefined situation when substituted back in the equation. So if I had something like 2 over x plus 3 is equal to 8, what if x was equal to 0? If x was equal to 0, then I would have an undefined situation, and that can't happen. So if 0 ended up to be a solution, that would be what we call extraneous. When you're solving rational equations, or any equation that has the potential for something undefined, like a variable in the denominator or a variable under a square root, those are some examples of situations like that, you have to check your answers to make sure you don't have any extraneous solutions. There will be frequent situations where you have extraneous solutions. You cannot give those as solutions to the equation. You would have to eliminate those as your solution set. So if I go back to this problem that we had a second ago, if I was to plug in 2/5 in place of that, I'd have 2 divided by 2/5, and even though that doesn't look very pretty, I know it's not going to be undefined, so this is a solution. Okay, now the next one, example 2, let's try the same thing. We're going to take a look at our denominators, and I want to have a common denominator. So as far as what they have in common, they have x and 2 and 1. So this on the far left, that already has an x, so it just needs to be multiplied by 2. So I can multiply this by 2 over 2. That's one way to look at it, and then this one doesn't need any of that, and this one needs the 2 and the x. And so I can look at it like that. Since, if you remember that example I showed you where if the denominators are all the same, we really just have to worry about the numerators, then one way that I like to just do this is I'm just going to say I'm going to multiply everything. I'm just going to worry about the numerator part. So if I multiply this by the 2x, and this by the 2x, and this by the 2x, this one, the x's cancel, and I'm left with 2 times 2. The 2x's cancel here, and I'm left with minus 3, and then equals negative 8x. And then I've got 1 equals negative 8x, and so x is equal to negative 1/8. Okay, that's my solution. I'm going to make sure that I don't have an undefined situation. 2 divided by 1/8 is not undefined, and 3 divided by 2 times negative 1/8 is not undefined, and that's really all you have to worry about. Remember though, as with any equation, when you solve it, you can always check your answer. So to make sure that x equals negative 1/8 is true, what I could do is I could easily use my calculator by storing it in x, and then I can just type in my equation 2 divided by x, subtract, and then 3 divided by 2 times x, and when I hit equals I should get negative 4, and if I don't, then my answer doesn't work. It does happen to work, so then we're good. Okay, example 3. This one has one factor, x plus 1, and another factor, x minus 2. On this side of the equation it has the exact same factors, so my least common denominator will be x plus 1 times x minus 2. So I can just multiply everything by whatever it's lacking. So this one is going to be multiplied by x minus 2, this one times x plus 1. This one doesn't need any of it, it's got both pieces of that least common denominator. So I'll have 2 times x minus 2 plus 3 times x plus 1 equals, and since I didn't have to multiply this right hand side by anything, it's just going to equal 1. So I don't have to worry about the denominators at all. So 2x minus 4 plus 3x plus 3 is equal to 1. That's 5x minus 1 equals 1. 5x is equal to 2. And so x is equal to 2/5. Double check to make sure I don't have anything extraneous. If you think back to our lesson on domain, I know that the only time I'm going to have a problem with my domain is if x is equal to negative 1 or if x is equal to 2. And since that answer is neither one of those, then this is a good answer. At least it's not undefined. You can always plug it back in and make sure. And again, I would just use the storage function of the calculator to plug it back in. Okay, example 4. The common denominator, I've got a 2, I've got a 5, and I've got an x. So this needs the 5, this needs the 2, and this needs the 5x. So I'm going to have 5 minus 4 equals 5x. And the reason why that works again is just because if I was to take 10x over 10x and multiply it by 1 over 2x, the 2 is going to cancel there, and the x is going to cancel, and I'm left with 5 over 10x, and then over on this other one I would have 10x over 10x times 2 over 5x, and so the x is canceled, the 5 cancels with a 10, the 2 would cancel with a 10, and I'd have 2 over 5x. Actually, I probably wouldn't want to cancel that much because I want to keep my denominators the same. So I'd have 4 over 10x. And then on the other side, if I multiplied by 10x over 10x, I'd have 5x over 10x. And so, since the denominators are all the same, they don't really matter. We can just look at the numerators and solve for that. And so that's why that works. So just take this equation now and just solve that for x. And so I'm going to have 1 is equal to 5x, x is equal to 1/5. Check for extraneous. 0 is a problem, 0 is a problem. That's not 0, so that at least is reasonable. You can plug it back in and check though and make sure that it really is true. So I would say 1/5, store it, a little store button in x, and then I would type in 1 divided by parentheses 2x, subtract 2 divided by parentheses 5x, and then when you hit equals, you'd better get 1/2, or else that means that your answer is not right, so you would need to go back and check that. Okay, the next example, I want you to pause the video, I want you to do this problem, and then play again and see if you get the right answer. Your common denominator here, you're going to have to recognize that that right there can be factored, or else you're going to get a denominator that's a little bit bigger than what you had hoped. So your common denominator is 2 times x minus 1 and then times x plus 1. This right here already has 2 of those pieces, it just needs the x plus 1. This already has 2 of the pieces, it just needs the 2. So actually this problem isn't so bad, because all you've got to do is this. So 5 times x plus 1 equals 30, and so 5x is equal to 25, and so x is equal to 5. I'm going to check to make sure there's no extraneous solution, so if I plug in 5 there, I'll have 10 minus 2 on the bottom, which is 8. That's fine. If I plug it in there, I'll have 6 times 4, and that's not a problem. I would check to make sure that it's correct. So 5 divided by 10 minus 2 is 8, and then 15 divided by 6 times 4 is 24, which reduces to 5. 3 goes in there 5 times, and 8 times, so that is true. Okay, example 6. Go ahead and do this one. I will tell you, you need to notice that you've got a quadratic down there that you cannot factor, so you'll have to take that into consideration. So try your best at this and then come back and see if you did it right. You can do this problem a couple of ways. If you recognize that you have a proportion here, that's probably the easiest way for this particular problem. And so if you wanted to do that, you could say negative 2 times x minus 4 is equal to 2 times x squared minus 2, and solve it that way. So that's one way to do that potentially. You are going to have a quadratic equation that you're going to have to solve. I'm going to actually erase this and do this another way just so that we can see. But I could say my common denominator is x squared minus 2 times x minus 4. So this one needs the x minus 4 piece, and this one needs the x squared minus 2 piece. So I'm going to have negative 2 times x minus 4, which if you notice your proportion, you're doing exactly the same thing. And this one is the 2 times the x minus 2, so we end up at exactly the same place. So negative 2x plus 8 is equal to 2x squared minus 4. Then everything needs to be put on the same side for a quadratic, so 2x squared plus 2x minus 12 equals 0. Before I solve that one, you could use the quadratic formula or you could factor, but before I did that, I'm going to notice that all of these are even, so I'm going to divide everything by 2. So I'll have something a little bit easier to solve. And that actually can factor. And so that means that x is equal to negative 3, or x can equal 2. And so those are potentially my answers. Now I need to check for suitability, make sure there's no extraneous. This right here would be a problem if x is equal to 4. Well, that's not one of my choices. This right here would be square root of 2, because square root of 2 squared is 2 minus 2. So that's not a choice either. So both of those are at least reasonable, and you would plug them in. There's 2 possible answers here, so they should both work one at a time. Plug them in and make sure. Alright, example 7. Pause the video, do the problem, and come back and see if it works. Okay, the common denominator is going to be x plus 4 times 4. And so this is missing the 4, this is missing the x plus 4, and this is missing the 4. So I'm going to have 12 plus 5 times x plus 4 equals, and then 18 times 4. So 12 plus 5x plus 20 is equal to 72. So 5x plus 32 is equal to 72, and 5x is equal to 40. So x is equal to 8. That does not cause any dividing by 0 situations, and if I plug it back in, I would have 3 divided by 12 plus 5/4, and you can check that, and that's the same thing as 18 divided by 12, and so that works. Okay, example 8, pause the video, try example 8, and then come back and see if you did it right. Okay, and this one, it's very important that you recognize that x squared minus 9 can be factored. So if you think back to the earlier parts that we did with this module, we talked about that a lot. That's just going to make your common denominator not so big. X squared minus 9 is x plus 3 times x minus 3. And so that's actually going to be what your common denominator is. This one is just missing the x plus 3. This one is missing the x minus 3. And this has everything. So I'm going to have x times x plus 3 plus 2x times x minus 3 equals 18. And so I'll simplify that. X squared plus 3x plus 2x squared minus 6x equals 18. So that's 3x squared minus 3x minus 18 equals 0. I'm going to notice that I can divide everything here by 3. And so that's going to give me x squared minus x minus 6 equals 0, which can be factored and solved by factoring. And so x is equal to 3 and x is equal to negative 2. So those are my potential solutions. Again, check for extraneous solutions. You notice that when I plug in x equals 3 right here, I'm going to have 3 minus 3 equals 0. That is not allowed, and it also causes a problem right here because 3 squared is 9 minus 9. That makes this an extraneous solution, so it's not a solution. So what we're going to say, since x equals negative 2 doesn't give us a problem, that's actually our only solution that we're going to give. And so you should have this on your paper, this x minus 3, but it should show that it's crossed out and that that's not one of your solutions. Okay, the last question in this module, or in this video, is this one. So go ahead and pause it and then come back and make sure you got it right. Okay, your common denominator is x plus 3. This one's got it. This one's got it. So you're just going to have 2x. And then this right here, be careful with that negative sign. It's minus 1 times and then the x plus 3 equals x. So 2x minus x minus 3 equals x. That's x minus 3 equals x. Think about what that says. A number take away 3 is equal to the number. And you think about what happens there. Actually doesn't make a lot of sense. If you subtract x from both sides, you're going to have negative 3 is equal to 0. That's never true. And so, as you know from previous experience, sometimes when you solve an equation, you end up with no solution. And that just means that you're never going to have an x that will make both of these true. If you were to graph this part of the equation in one part of your y equals on your calculator, and then if you graph this one as another one, you would see that they actually never intersect. So if you think about systems of equations, these two never intersect, and so there's no solution. There's nowhere that they're the same. Okay, so now you can complete your packet through the next section, and then there is one more video.